In this lab, you will create a mechanical symbol to match the following design and dimensions. Start the Allegro PCB editor if you don't already have the software running. Choose File, New, File, and New. If a notifications window comes up and you've already saved whatever you had on the Allegro editor, you can say no. User interface will come up and it'll ask you for a drawing name. In this drawing, I think we'll call it outline. And the drawing type will be a mechanical symbol. And then you can say OK. We'll now set up the design parameters, and you can click on Setup, Design Parameters, and you're going to notice that there's several folders that you can look at. The one we're really need is the design, and the units are going to be in mils, and the size is going to be an A-size drawing because it's a small file. Accuracy, I usually use 2. 2 is more than enough. And the long name size is 255, which is more than enough. And the extents, now this is where we put our 0 point. I always like to have it a -2000 and a -2000, which usually always works. The width is 11,000 and 8,500, which is 11 inches and 8.5 inches. Remember, mils is 1,000 mils to an inch, and that's how we arrive at the letter size drawing. As far as moving the origin, we're going to say 0 and 0 because we don't need to move it, and the type is mechanical, which is correct. And we don't have to do any line lock adjustments at this time. So we'll just say OK. And if we look at our drawing, we see a little point here. This is our 0 point, 2 inches in the left and 2 inches down. And this is where our drawing will be. The next thing we want to do is click the Display tab in the Design Parameters form. Just like that. We want to click Grids On in the Browser button, and we want to click the Setup Grids button. The Grids display form appears. And we want all our grids to be 25 mils. And that should do it. If you notice, we have non-etch 25 and 25, and the top and the bottom at 25, 25, and 25, and 25. And that's exactly what we need. And click OK. As indicated in the mechanical drawing at the beginning of this lab, the datum 00 point for this outline is the center of the lower left mounting hole, which is this mounting hole right here. Choose Shape Polygon. In the Options window, set the active class and subclass to Board Geometry and Design Outline if necessary, as right here. And the type we want as unfilled. And in this case, we're not using any 45-degree angles, so the segment type can be orthogonal. So the first point that we have to add to this outline is right here. And remember, our 00 point is right here. Now we know the dimension from this point to this point is 380. And we also know that the distance from this point to this point is 410. So we have to do a little math in order to get from this point to this point. So we have to find this distance from this point to here, and then we have to add 850. So here's the math that we need to get to that point. We have the 4.1 inches, which is right here, and we have the 3.8 inches right here. So we subtract 380 from there, which is equal to 300. Now we have to divide that by 2, because remember we have a space here and we also have a space here. So that's why we divide it by 2, which equals 150. Now 150 brings us right to this point here. Now in order to get to this point, we have to add your 850, and that will give you 1,000 and 0 in the y. And remember, since we are going to the left of the mounting hole, we have to put in x space minus 1,000 space 0, because the y is at the 0, 0 point. And we can just hit an enter here, and this is our line. Now remember, if we look at our drawing, it is a 0.85 in the x, and that will be an incremental move. And remember, the incremental move is IX 850. Hit a return, but put your cursor there, and there we go. And now we have to go down, and we have to go down from here to here. And remember that this one is a very simple problem. Just take 450, subtract 4.1, and you're going to get 40 divided by 2. So we know that we have to come down 0.2 inches or 200 mils. And this is a list of all the XY coordinates that we have to put in. Notice the first one is an x, which is an absolute, and then everything else is an incremental. This is the one that we had to do a little math for, which is an IY minus 200. And then this is a listing of all the moves that we're going to be doing into this design, and we'll do this a little quick. Well, you can save this and follow along. IY minus 200. IX 4100. IY 4500. IX minus 4100. Remember, it's going to the left. And then we go IY minus 200. Remember, we're going down. And we have a minus IX minus 850. And an IY minus 4100. Again, going down. And that completes our polygon. In this part of the lab, you will add 3 holes. To define these tooling holes and mounting holes within a mechanical symbol drawing, you must add them as pins or pad stacks. Choose Layout Pins from the top menu. And in the Options tab, click on the Browse button. The pad stack we want is hole 110. And you're going to see lots and lots and lots of pins. If you want to do a little bit of a shortcut, you could go H and asterisk, and that should bring us to all the H's. And our hole 110 is right at the top. We're going to click it and we're going to say OK. This is the pad stack that will represent the mounting holes on this board. And if we look in the message area right here, we see using hole 110.pad, which is correct. And if we look at our mechanical drawing, this mounting hole is 0, 0. This mounting hole is X space 3,800. And this one is Y 4,100. So the first one we put in is X space 0 space 0. And we see that flies right in there. The next one is X space 3,800 0. And that flies right into there. And the next one we put in is X space 0 space 4100. And that flies right into there, and our mounting holes are installed. You now use the Shape Edit application mode to add the 45-degree chamfers to the corners of the board outline. Then you add dimensions to the mechanical part. And we choose Setup, Application Mode, and Shape Edit. Be sure to open the Options tab, and you will see the user interface for the chamfer. We want to set the trim to 50, and I'm going to do a window zoom into this point right here, and we want to put the cursor on the point until it changes shape, and click. And you do that for the remaining 6 corners. We will now add the linear dimensions. To ensure the extension lines don't run into each other, extension lines are the ones that contain the dimension value in the example shown. You need to set the dimension parameters first and then add the linear dimensions. So we choose dimension and the dimension environment. We right-click and we go to parameters. And we select the lines tab, and we see that the offset distance from the element in this case is 0.1, and we really want it to be a 0.250 inch. So we put that in there. The distance beyond the dimension line is 0.10, and that's fine. We click OK to close the dimension parameter form. So we can zoom in if we'd like into this area. This is what we're going to be dimensioning next. And we right click and we look for linear dimension. And we click on this point and this point. And we bring it down, we click. We see our dimension here. And just click. And also notice our extension lines are offset from the outline. Now I want to add a dimension here. Dimension here is too close. So we're going to move it and we're going to right click, and then we see that we go into the move text routine, and that allows me to bring this down and then we'll go in and we'll dimension this point. So we get back into linear dimension. Remember, this is a right click to get this up, and then we click from here, and we click here, bring it down, and done. And what I really want to do is dimension these mounting holes here, because if we go up, we only had one mounting hole, and this would be the best way to dimension the distance from this mounting hole to this mounting hole. So let's delete this one, and I wanted to show you that you can do a delete, and the delete dimension is here. We just click on it and it's gone. And then we're going to go back and we're going to do linear dimension again, and this time we're going to do the mounting holes, and that's done. Still in the dimension edit mode, and let's finish up our dimensioning. And we can turn off our grid so we can see our dimensions a little better. And looks like we're done as far as dimensioning goes. Except we also have to put the chamfer. So to put in the chamfer leader, we right click and we look for chamfer leader. And why don't we zoom in so we can see it a little better. Click on that, let's window zoom, and we put our cursor here and we left click, and that automatically gives us our dimension. I click, bring it over a little bit more, and maybe to about here, click again, and just say done. To place the final note text specifying the number of chamfers on the board, choose the Add Text menu item. Add Text. And then we come over to this Options folder. We want to make sure that this is in Board Geometry and Subclass Dimension. The marker size can be 50, and the text block should be 4. And just click on the board and type in your text. After you type in your text, you can hit a return, and if you want to move it, you just go into your move routine, which is right here, and click on your text and move it anywhere you like. And you can say done. In this part of the lab, you create package and route keep-in areas to define the available board areas that you can use for part placement and signal routing. Choose Edit, see Copy Shape, and the class should be Package Keep-In, which would be right here. Subclass All. And notice that you can contract or expand the shape. In this case, we're going to contract it. And we're going to contract it 70 mils. So we change this to 70. And we click on the polygon. And we see that our package keep-in has been contracted. And if we zoom out, you can see that it has done it through the whole expanse of the board. We Now want to add our route keep in area, so we change this to route keep in, and the subclass is all, and our offset on the route keep in is going to be 50 mils, so we just type in 50, and we can click on the board outline again, and we see that now we have a 70 mil contracted route keep in. We now want to add package keep out and route keep out areas around our mounting holes. And we go into our shape and circular routine, and we want to make sure that the active class is package keep out, and we zoom into our mounting hole, and let's use a window zoom right here. The next thing we want to do is add a package keep out and a route keep out area around these mounting holes, and to do that we go into shape and circular there, and we see that we're in route keep out all, which is correct, and we put our cursor in the middle of the pad, and then we make it come out just to about there, just so that we have a nice route keep out area around the tooling hole. And then we also want to do the same thing to package keep out, which is right there. Oops, that's a package keep in. Let's make that package keep out. Very good. And do the same thing here. And we're all done. Do that to the other two holes. Now the engineer has told us that he wants this area to be completely free of vias. So we're going to put a via keep out area in here. Now since we don't have it dimensioned in this drawing, the engineer has just given us the X and Y coordinates, and we will just simply put the via keep out area in this area right here. So we will start our rectangle at x minus 900, 200, and then we'll go in IY 3700, IX 450, and IY minus 3700. So we start with setup areas and via keep out. We type in x minus 900, 200, IY 3700, IX 450, IY minus 3700, and then just click done. And that completes our via keep out area. And that concludes our creation of our board mechanical symbol, and we just say File and Save. We say yes because we do want to overwrite it. And if you notice, it also created our outline BSM, which is what we'll be importing into our board file. and that takes care of that. And then we do the same thing for a route keep out. That, click in the middle, and that adds another one right there. And now we want to do the same thing. We want to do a shape, circular shape, and we want route keep out. So we click into the middle, and that puts in our route keep out. The next thing we want to do is add a package keep out and a route keep out area around these mounting holes. And to do that, we go into shape and circular there, and we see that we're in route keep out all, which is correct. And we put our cursor in the middle of the pad, and then we make it come out just to about there, just so that we have a nice route keep out area around the tooling hole. And then we also want to do the same thing to package keep out, which is right there. Package, oops, that's a package keep in. Let's make that package keep out. Very good. And do the same thing here, and we're all done. Do that to the other two holes. Now the engineer has told us that he wants this area to be completely free of vias. So we're going to put a via keep out area in here. Now since we don't have it dimensioned in this drawing, the engineer has just given us the X and Y coordinates, and we will just simply put the via keep out area in this area right here. So we will start our rectangle at x minus 900, 200, and then we'll go in IY 3700, IX 450, and IY minus 3700. So we start with shape, and it'll be a shape, polygon. So we start with setup, areas, and via keep out. We type in x minus 900, 200. IY 3700, IX 450, IY minus 3700, and then just click done. And that completes our via keep out area. And that concludes our creation of our board mechanical symbol, and we just say File and Save. We say yes because we do want to overwrite it. And if you notice, it also created our outline BSM, which is what we'll be importing into our board file.